Hello class, I hope everyone's doing very well when they start watching this video. Today we're going to be talking about Newton's second law. So, as always, some good questions to get us started is what is Newton's first law of motion? Can we remember from our last presentation or last topic on what was the definition of Newton's first law? We said it was an object in motion will stay in motion and an object in rest will stay in rest unless acted upon by an unbalanced force. And our objective for today is just to understand the basics of Newton's second law. So we have a good video that I will link in our classroom as always, so please go watch this before we get started. I think it's a good introduction to what we'll be doing. But once you get back from watching our video, today we're going to be going over the basics of Newton's second law. So first, Newton's second law is defined as F is equal to m times a, where our force, or F is force, which is measured in newtons, and a newton is a kilogram times a meter per second squared. Our mass is in kilograms, and our A is acceleration meters per second. We can also do some math, some algebra to move this equation around and solve for different things. So our first one, F equals ma, is really good when we're trying to solve for our force, but if we want to solve for our mass, we can use m is equal to F over a. And if we want to use our acceleration, we can use our a is equal to F over m. And we can see that over here really nicely in our picture. I'm covering up this one picture, so I'm going to make it a little bit smaller just so we can see it. I think it's important. Sorry about that. There we go. So, but we can make this nice little triangle to help us remember. So if we make F over ma, if we're solving for F, we're going to multiply m times a. If we're solving for m, we're going to take F and divide by a. If we're solving for a, we're going to take F and divide by m, and we can see that all down here. So we can use these three different forms of F equals m times a to help us solve any problem we want to. But another idea is when we're looking at this equation, we can see F is equal to mass times acceleration. So of course, the more force, the more acceleration. The bigger our force is, if we keep the same exact mass, we're going to have a bigger acceleration. Or another example is if we have the same acceleration, but a smaller force, a smaller mass, we will have a smaller force. So we can see how these are connected. If we keep one constant, then it becomes an inverse relationship. So as one gets bigger, the other one will get bigger, or as one gets smaller, the other one will get smaller if one of our things stays constant. So we're going to watch a demonstration here. The idea is that we're going to take a small ramp with a full can and one with an empty can. And then we're going to let them go at the exact same time and see which one will go faster. And then we'll look at why. Why is this happening? So this is just a quick video we'll watch. So we can see this one with the hole is open, the one that's closed is full of Coke. Let's pause this real quick. He's going to remove our little stopper, and then we're going to watch them roll down a ramp and see what happens. And why. So we saw that the full can of soda traveled a lot faster. It rolled a lot quicker down the ramp than our other one did. So let's look at what else we're going to see. Oh. So that time we saw that we had three different size steel balls. We had a small, a medium, and a large one, and we could see that the medium one, we can see our largest one was the fastest, then our medium, and then our smallest was the slowest. And this is all because our mass is changing. What we're looking at here is our mass is changing, and so our acceleration is going to change. If we have more mass, we're going to have more acceleration. So that's just a good demonstration to show how to do it. Some important notes is if we're given the same mass, more force will result in a higher acceleration. So if mass is constant and we have the same, given mass, more force. Oh, yeah, so if mass is staying the same and we increase our force, we're going to increase our speed. If we keep mass the same and we decrease, if we make our force less, our acceleration will be slower. Another important note is when we have objects that are falling in the air, our acceleration, A, is gravity, so it's going to stay constant. So anytime we drop something, gravity is the force acting on it. And so gravity is always going to be the same anytime we see something fall, and that's going to be at 9.81 meters per second squared. So just an important note to remember as we start doing some of these problems. So here are some of our examples that we're going to be doing. The idea here is a baseball is falling off a table. If the baseball weighs 2 kilograms and the acceleration of gravity is 9.81 meters per second, what is the force of the baseball? So just like we've done all of our problems, we always start by writing down what we're given. So we want to write down whatever our numbers are, but in terms of our variables. So when we see kilograms, we think mass, we think m. And then when we see acceleration is a, and it's measured in meters per second squared. So we only have two numbers. We have our mass and our acceleration. The next thing we're going to write down is our equation that we're going to use. That's always important to write down the equation we want to use because it makes our next step really easy. So we're going to use F is equal to m times A. And now all we have to do is replace our letters with the numbers that we just decided. So if we decided m is equal to 2, we're going to put a 2 kilograms here. And we decided A was equal to 9.81 meters per second squared, so we'll put 9.81 right there. So our work is just plugging those in. And then our answer is 19.62 newtons. So it's, I think, a very easy equation. The hard part is just making sure we're understanding our problem. So let's go through a couple more examples. Mr. Mike kicks a soccer ball, making it move with an acceleration of 15 meters per second squared. If the soccer ball weighs 3 kilograms, how much force was his kick? So, of course, we always start with what's given. We say our acceleration is 15 meters per second squared, and then we say the ball weighs, or our mass, is 3 kilograms. So we plug in m is 3, acceleration is 15. Then we use our equation, F is equal to m times A. Newton's second law, force is always equal to the mass of an object times its acceleration. And then we just get to plug in our numbers to our equation. So we're going to end up having 2 kilograms times 15 meters per second squared, which is going to be 30. Oh, sorry, this should be a 3. That's why. Sorry, I had a mistake in my presentation there. So F is equal to 3 times 15 meters per second squared. Sorry about that. And so our answer is 45 newtons. So let's look at a couple examples where we don't just where we're not just looking for our force, but we're looking for something else. So Mr. Max throws a large rock with a force of 500 newtons. If the rock weighs 15 grams, what is the acceleration of the rock? So A stands for acceleration. That means we need A is equal to something. Our question is, what is the acceleration? So first we're going to write down our givens. Force is 5,000 newtons, mass is 5 kilograms, and then for our equation, we're going to use the one that has A, acceleration is equal to something. And we're always going to use our givens are going to be help us determine which equation we're going to use. If we're given F and M, we're going to find A. If we're given M and A, we're going to find F. And if we're giving F and A, we'll find M. So that'll kind of help us based on what we're given. But our equation is going to be A is equal to F divided by M. And then again, we're just plugging in our numbers. So acceleration is 500 newtons divided by 5 kilograms, or our acceleration is 100 meters per second squared. So it's very, very fast. All right, our next example is Miss Brenna drops a box from a tall building to see how much it weighs. when falling, there is a force of 3,000 newtons and acceleration of 9.81 meters per second. How much does the box weigh? So what we're given is a force of 3,000 newtons and an acceleration of 9.18. This 9.18 is gravity, like we mentioned earlier. So we're going to write down our givens, our variables. Force is 3,000, acceleration is 9.8. And then we're looking for how much it weighs. We're given an F and an A, and we're looking for how much it weighs, so we're going to use this equation. And then, again, it's as simple as plugging them in. So we're going to say 3,000 divided by 9.8 is 30.6 kilograms. So our box weighed 30.6 kilograms. So those are the examples I have for you guys today. I hope that our presentation was straightforward, and always, if you have any questions, though, please let me know.